Welcome to another math problem of the week. 3 random chords and a triangle. Let's talk about it. For today's question, we are asked to create 3 random chords on a circle. 2 points are chosen uniformly at random along its circumference, and this process is repeated twice. The resulting chords are then used to cut the circle into multiple pieces. What is the probability that one of these pieces is a triangle? And the options are A, 1 over 10, B, 1 over 12, C, 1 over 15, and D, 1 over 18. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
Now let's try to understand this question again. We need to create 3 random chords on this circle. So first of all, we randomly choose any 2 points and form a line. Then we repeat this process twice. Points and form a line. And the last 2 points, form a line. For this example, we see that we have 1, 2, 3, 4, 5, 6 pieces. We can't find any triangle in this diagram. This means that the only way for us to get a triangle is as follows. So 2 random points, create a chord, and another 2 random points, another chord, and 2 random points, another chord. If we do it this way, then we will have a triangle in between. This is one example that we successfully to create a triangle among all the pieces. So we can actually think of this question as we have 6 random points on the circumference of the circle. For these 6 random points, we can first choose any of them to create a chord. Then we choose another 2 points out of 4 remaining points to form chords. And finally, we have the last one. With this, we create 3 random chords with different order. We have to divide 3 factorial. And this number means that the number of possible ways to create different chords. So it is equal to 1 over 6 times 15 times 6 times 1, and there are 15 ways. Since there are only 15 ways, we can list out all of them and see what are the possibilities. These are all 15 possibilities. Out of this possibility, only one of diagram will give us a triangle. That is, although in this graph it looks rather small, but there is a triangle that created here. The rest, we won't have any of them. Obviously, the probability is 1 over 15. So out of all the responses I received, they use a similar argument. They all agree that there will be 15 possible arrangements altogether, and only one of them is possible to fulfill the condition. And for this, they use a similar argument. Instead of drawing the diagram, they list out using the vertices A, B, C, D. Essentially, they are the same idea. Likewise for the rest of the responses. That's all for today's lesson. I'll see you on next Tuesday. Bye bye.